My name is Jonathan Parker, center number 64630, candidate number 9071. This is video evidence of my AQA GCE A-Level Computer Science 7517 non-examined assessment project titled Dijkstra's Algorithm Solver. To begin, I'm going to create a graph of nodes. By pressing the Create New Node button, I can spawn a series of alphabetically labeled nodes onto my graph. These can be dragged around freely with the mouse. I'm then going to create some connections for my graph by pressing the Create New Connection button. I am then prompted to select the start and end nodes for this connection. Since my graph is currently weighted, I am then required to input the weight for this connection, i.e. the total cost to traverse this connection. As I drag nodes around, the node labels, connections, and connection labels for the given nodes all remain perfectly attached. I'm now going to create some more connections for my path. Notice that decimal numbers are supported, and the size of the node of the connection label scales appropriately to the length of the number. If my number is too long, I can press the backspace button to delete characters. I'm now going to select the start and end nodes for my path. These are indicated by the green and red nodes respectively. The system then checks if there is a valid path between the nodes and begins pathfinding after the find shortest path button is pressed. The shortest path is indicated by the blue colored nodes and connections, with the distance of the path shown at the top of the screen. By pressing the Show Explanation button, I can bring up a detailed step-by-step instructions of how the system is solving the path. Each step of the solution references the associated step within Dijkstra's algorithm, which can be shown by pressing the Show Algorithm button, and hidden again using the Hide Algorithm button. Within the window, I can scroll through the menu using either the mouse scroll wheel for PC or by dragging the text, particularly useful for touchscreen and mobile devices, or by dragging the scroll bar on the right. Notice the detail of the descriptions for each step. Furthermore, in addition to the standard weighted graph as shown on the screen now, my system also supports unweighted graph, where every connection has an equivalent weighting of 1. This can be toggled on and off using the Toggle Weighted button. As the system switches to unweighted, the connections labels disappear as they are no longer needed. If I then find the shortest path again, my system will update the path and the distances appropriately, as shown on the screen. In addition to this, my system also allows the use of directed connections, i.e. connections which can only be traversed in a given direction. The direction of a connection can be toggled by pressing the Toggle Direction button and then clicking on the chosen connection. I can click more than once to toggle it further, or return it to its original undirected state. For the cases of this test, I'm going to have it directed C to G, which would make it untraversable if the current path was followed. When I am done, I can exit out of this mode using the cancel button as I just did. If I then run the pathfinding again, the system adjusts the graph to reflect that it can no longer travel as it was previously able to due to the new directions. Finally, nodes and connections can be deleted using the Delete Object button. This is also taken into consideration when the pathfinding is executed again, as the path is now forced to take this longer route. If I then delete the path to the end node and attempt pathfinding again, the system will identify that there is no path between the start and end nodes and will not begin pathfinding as shown at the top of the screen. Thank you.